Okay, we've got some more pandemic math on tap. This is pre-cal, and this will be lecture 7.1 and 7.2. So 7.1 is called Introduction to Linear Systems. All right, so a system of linear equations is simply a group of lines. The points that the lines have in common are the solutions of the system. Okay, so let's give some examples here. So let's say we have a line that goes like that, another line that goes like that. This system would have one solution right where those two lines cross, a single point. All right, so a point shared by both. All right, how about we have this situation where we have two parallel lines. All right, so they never cross. Okay, we would say that it has no solution. So what happens if you try to solve this system, you would get like something, your answer would end up being false. You'd have something like 0 equals 3. Okay, so if you end up with something like that, you've got no solution. Okay, if you need to pause the video, go ahead. And then the third situation, let's say you had two lines. Do one in black and try the other in blue. Two lines that are just right on top of each other. In that case, you'd have an infinite number of solutions. Okay, so if that's the case, you would end up just getting a true statement, like 3 equals 3. Something like that, in the end. Okay, so that's just a little introductory 7.1. Let's move on to 7.2. 7.2.1 is called solving a system. So it's systems of equation, a system of equation. We're just going to call it a system by substitution. Okay, a little definition here is in the substitution method, we solve one equation for y or it could be x, either way. So, or x. And substitute that expression into the other equation. Okay, so let's do a simple example here. So our first example is, let's say we have y is equal to 4x minus 3. We also have y is equal to 3x minus 1. And we want to know where do these lines cross. Okay, so ultimately we're trying to get a point, an x value and a y value, a point where they cross. So what you could just do is substitute. We know that y is equal to 4x minus 3. We know y is also equal to 3x minus 1. We're just going to substitute that entire expression in for y, and then we'll just have one unknown. Okay, so we could substitute it. 3x minus 1 is equal to 4x minus 3. Okay, so I'll shoot this 3x over to the right. 4x minus 3x would just give us x, and then add 3 to both sides. So that would be 2. So we have our value for x. 2 is equal to x. How do we get y? We're just going to substitute into one of the two equations our x value. So how about that right there? So we'd have y is equal to 3 times 2 minus 1, which is 5. So the way that you would show this answer is a point 2, 5. X is equal to 2 and y is equal to 5. All right, so let's do one a little more challenging. Little fancier answer. So let's solve this system. We'll have 3/4 x plus 4y is equal to 10, and y is equal to 1/2 x. Okay, so we'll substitute that 1/2 x in here for y. So I'd have 3/4 x plus 4 times 1/2 x is equal to 10. Excuse me. So I've got 3/4 x plus 4 times 1/2 would be 2x is equal to 10. If you want, we can just get rid of that entire fraction by multiplying the entire thing by 4. Okay, that'll get rid of the 4 in this denominator. You don't have to do it that way, but I'm going to go ahead and do that. So 4 times 3/4, the 4's canceling. You have to have 3x plus 8x is equal to 40. So 11x is equal to 40. X is equal to 40 over 11. So now we can substitute, we can use this equation y equals 1/2 of an x. So I'd have 1/2 times 40 over 11. Excuse me, I need to get a drink. Okay, so our solution, where do those two lines cross, would be 40 over 11 and 20 over 11. So boom, don't let the fractions scare you. They're not too bad. Okay, so that's substitution. Let me do a couple of examples of elimination. All right, so pause video if you need to. So 7.2.2 is solving a system by elimination. Now this is really a Algebra 2 or even an Algebra 1 topic, depending on where you went to school. But this is going to lead to matrices. Okay, so this chapter, chapter 7, spends most of its time working with matrices. So this is kind of an introduction to that. So in the elimination, you start by manipulating the equations. So that the coefficients of the x terms or the y terms are equal. Then subtract the two equations to get an equation with only one variable. Okay, I think I got room to do our first example beneath all of this explanation here. So let's say we have 3x plus 4y is equal to -5. And our other equation is x minus 5y is equal to -8. So we want to solve using elimination. So it's legal to multiply these equations by whatever you want, as long as, or divide, as long as it's the entire equation. All right, you don't. So it's probably easiest to eliminate the x. Okay, because I can multiply this entire second equation by 3. All right, if I multiply that entire second equation by 3, then I could subtract it from the first and get rid of the x. Okay, so let's drop this first one back down. 3x plus 4y is equal to -5. Multiply the second equation by 3, and I'd have 3x minus 15y is equal to -24. And then I'm going to subtract the second equation from the first. So here's our elimination. So 3x minus 3x, the x term goes away. 4 minus -15 would be 4 plus 15, so that's 19y. And -5 minus -24 is -5 plus 24. That's 19. So y is equal to 1. All right, now I'm going to substitute that back in, and I'm going to work with my second equation. If you have x minus 5y is equal to negative 8, let's just solve for x. X equals positive 5y if you move the negative 5y to the right of the equal sign, minus 8. And then we'll just substitute the 1 in. So x is equal to 5 times 1 minus 8, and that's negative 3. So we can write out this solution as negative 3, 1. All right, so that's a pretty simple elimination. If you need to pause the video, go ahead, and we'll do one that's a little more complicated. Okay, so this example, let's say we have 3x over 5 plus 2y over 3 is equal to 17. And negative x over 3 plus y over 2 is equal to 1. Now, first of all, what I'd like to do is eliminate the fractions. I don't like working with fractions. So for this one, this first one, if we multiply the whole thing by the least common multiple, okay, so for 5 and 3, that would be 15. If we multiply that whole equation, 3x over 5 plus 2y over 3 is equal to 17. If we multiply that whole thing by 15, 15 over 5 is 3, times 3x would be 9x. 15 over 3 is 5. 5 times 2y is 10y. And then 15 times 17 is 255. Now, what would we multiply this second equation by to eliminate the fraction? What's the least common multiple? All right, it is 6. Okay, 6 over 3 is 2, times negative x would be negative 2x. 6 over 2 is 3, times y would be 3y. And 6 times 1 is 6. Don't accidentally write a 1 there. I've had students do that a lot of times. They'll get rid of the fraction and forget to multiply by the constant. Okay, so I'm going to just rewrite those two equations right here, and we'll decide what to do to eliminate one of the variables. Okay, so probably the easiest thing to do, and you could work with either x's or y's here, but if I multiply this top one by 3, then, or excuse me, by 3. And I multiply the bottom one, the bottom equation, by 10, I'll be able to eliminate the y. Okay, I'd have 30y in both. So if we do that, if we multiply this entire equation by 3, I'd have 27x plus 30y is equal to 765. And then the second equation, I have to have negative 20x plus 30y is equal to 60. Now I'm going to subtract the second equation. Now you could multiply the whole thing through by negative 10 and then add. That's fine. Whatever you like better. Okay, so 27 minus negative 20 is 47. 30 minus 30 is 0, so we've eliminated the y. And then 765 minus 60 would be 705. So you might need your calculator handy, but 705 over 47 is actually 15. Now what I'm going to do is use the simpler of the two equations and substitute 15 in. And I think that obviously the second one is the most simple of equation. So we'd have negative 2 times 15 plus 3y is equal to 6. It's negative 30 plus 3y is equal to 6. 3y is equal to 36. Adding 30 to both sides, so y is equal to 12. So the answer to this solution, and of course you could go check it by plugging them back into the original equations, plugging 15 and 12 and see if it works. So there you go. So that completes lecture 7.1 and 7.2 for pre-cal, and we will see you next time.